Hello children, welcome to our next class and today we'll discuss on Newton's third law of motion. Before this we'll discuss about Newton's first law of motion. There we've got that Newton's first law defined the force. Then we have moved to Newton's second law of motion which measures the force. There we have got the concept of momentum. Momentum is the measure of motion in a body. The moment of motion on a body is known as momentum. After that, we have moved to impulse, which is the span of time for which force works on a body. Now, when the body we are talking about, that means two or more body. The body, one which is applying the force, and the body which is experiencing the force. So that means there comes a new word which is known as system. A system is a combination of two or more body where one body is applying the force and other body is experiencing the force. So Newton has done the third law of motion, that is known as Newton's third law of motion. Newton's third law of motion. It is one of the easiest law in the mechanics because that is true in our religious belief also, that every action has equal and opposite reaction. If you're good, good will come to you. That the mythology believes on it. So the outcome of Newton's third law of motion is to every action there is an equal and opposite reaction. So here two words are introduced. One is action, another is reaction. What are these? Action and reaction. What we are doing, we are giving a punch to this wall. We are giving a punch to this wall. Then what is happening? Only the wall is getting hurt, or your fingers are also getting hurt. You can do and see. Yes, the wall is getting hurt, we are getting by the sound, but our fingers are getting hurt, that's we are feeling. So what has happened? The action is the punch is given on the wall. The reaction is wall also hit the finger. So that means at a time two things happen. One is the action and another is the reaction. In all frame these things are happening. So the action and reaction pairs is helpful to define Newton's third law of motion. That to every action there is equal and opposite reaction. In all fields these same things happen. Let's we are taking a ball and we are thrown to the ground. The ball will come to us. Why? Because the ball had hit the wall. At the same time, the wall has also hit the ball and it has come to the opposite direction. So the equal and opposite reaction. Action is doing and reaction is doing on its opposite direction. So here one question arises, that if action and reaction are taking place, is the result of action reaction pair is 0? Yes, please think and try to answer it. Yes, it can't be 0. The result of action and reaction can't be 0, though they are equal, because action and reaction works on two different directions. Action and reaction are working in different direction. So the action is there, the reaction will be in the opposite direction. So the result of action reaction pair is never 0. Let me illustrate about the motion of human body. When humans moves, what we generally do? When we move, we apply some force on the ground, that is by our toe. Suppose this is our toe and we are applying a force at angle theta with this surface. This the theta is the name, Greek name. You can write alpha, beta also, or even a, or your name also, that is the assumption. So this is the surface on which the human is applying the force. So this force is getting two components. One is the vertical upward direction and another is the horizontal component. Now neither we are thrown in upward direction nor we are sinking. So this component are cancelling each other. When you are walking, okay. So neither you are getting sink if the surface is not muddy, nor you are thrown because the gravity is there. So what happens? You are moving forward. You also walk every day. The same things happens. So this component is F cos theta and this one is F sin theta. Why cos theta? Because this is a B, this is H and this is the P, perpendicular. So trigonometry will talk to you in next class, but let's have the idea of this trigonometry that this F cos theta is moving of forward direction. So by this only we move in forward direction. So this is the action, and this is the reaction. So walking of human being is an example of Newton's third law of motion. Our next example is the swimming of human. While you swim or you see the video of a swimmer, they will see the swimmer try to pull the water back. The swimmer try to pull the water back. At the same time, water is pushing the person front. So action is what? Swimmer is pushing the water back. Reaction is the water is pushing the person ahead. So again, by the action and reaction, the human swim or animal swim. The boat are designed on this principle. A boatman or a person who are driving the boat used to roll the water back. Doing so, they are pushing the water back. So the water is pushing the boat forward direction. In every case, these things are taking place. Okay. So there we are discussing about the Newton's third law of motion. So what two words we have come? We have come the action and reaction. Based on that, we will now derive the law of conservation of momentum. Next topic is, if you want to write down, you can pause the video and write it down. Okay. Now we are moving to law of conservation of momentum. What is that? Law of conservation of momentum. In absence of any external force, the momentum of a system remains conserved or constant. In absence of external force, the momentum of a system remains constant. Here we are again going for a word, that is system. What is system? System is a combination of two or more bodies. Suppose two balls are colliding. Might be both of them are in motion or one is in motion. After the collision, what happens? They used to move in different direction. Maybe they will stick on each other, but their motion will exchange. The speed will vary. Same thing happened in the collision of vehicle also. They were getting that when the vehicles are colliding, then they impart momentum on each other, and due to that momentum only, the damage occurs on the vehicle, because momentum means the product of mass and velocity. So they are colliding. By the concept of this law of conservation of momentum, the damage will occur, that the body in high speed will get more damage because the change of momentum will be also more. So what is the things that momentum, if we are talking about collision, then momentum before collision is equal to momentum after the collision. For any system, this rule is working. Like firecrackers. When a firecracker bursts, the firecracker has so many parts. So if you add the momentum each and every part of that firecrackers, including the heat and sound produced there, then the momentum of that body is equal to the momentum of actual firecrackers. So law of conservation of momentum is mathematically 100% correct. Conditionally, the this condition will be applied. On this principle only, the jet plane and rocket start to propagate or propagate in air. Because while propagation, a rocket left so much amount of gases in downward direction. These gases are releasing from the jet plane or rocket. They are giving the momentum to this body in a forward direction. So by the exertion of that gases, the rocket move in the upward direction. There also this principle is carried on, that is momentum before the motion is equal to momentum after the motion. The recoil velocity is also example of that. As a combination of acceleration pair, you can tell about that Newton's third law is satisfied or action reaction pair is satisfied. Because when a bullet is fired, the bullet moves in forward direction, but the gun also moves little in the backward direction. That's why the person in the military are well trained for running the different type of devices, because this principle is carried there also. For today only, you just discuss about these things, law of conservation of momentum. You don't write anything, you please see the video 2 or more time. In next video, we will prove this law of conservation of momentum. Till then, enjoy your day. Thank you.